Let us continue our discussion and learning of the subject Advanced Machine Learning. This is the syllabus, and we are into Unit 1, which has types of machine learning algorithms, linear algorithms, feature vectors, learning problem formulation. If you remember session 1 of the introduction, we had referred this textbook by Jason Browning for that introductory concept. The name of the book is Master Machine Learning Algorithms, and in the session 1, just if you make a walkthrough of this, we use Jason Brownlee's book by name Master Machine Learning Algorithms, and we had seen what are linear algorithms, what are non-linear algorithms. Say for example, linear regression, logistic regression, LDA can be linear, then k nearest neighbor, support vector machines can be non-linear. Then we mentioned ensemble algorithms such as bagging random forest, boosting and ADA boost. We defined machine learning algorithm as a function y is equal to f of x, where f is the target function which maps into variable x to an output variable y. We then mentioned parametric machine learning algorithms such as logistic regression, LDA, perceptron. Non-parametric machine learning algorithms such as support vector machines, CART at C4.5. Let us continue our discussion for the introductory topics, that is supervised, unsupervised, semi-supervised, reinforced learning as an introduction part. So this is the function which defines a supervised learning algorithm. Here x is an input variable, y is our output variable. We are using an algorithm which will be mapping function from the input to the output. What is the ultimate goal? Mapping function should be good, okay, so that if you have any new data, then you can predict the output correctly. Why supervised learning algorithms are called as supervised? So there is a training data set. As there is a training data set, we can think it of as a teacher supervising the learning process. We know the correct answers. What the algorithm does? Repeats, makes predictions on the training data, and those predictions are corrected by the teacher. Learning will be stopping when the algorithm achieves an acceptable level of performance. So performance measures are used for that purpose only. Supervised learning can be classified or categorized further into classification and regression problems. What are classification problems? You have a class label such as yes and no, salary greater than 50,000 or no, color is red or blue, disease is there or not there. Or regression problems where the output is a real value such as weight in kilograms or dollars. The problems such as recommendation systems, time series predictions, they fall under classification and regression. Few popular supervised machine learning algorithms are linear regression, random forest, support vector machine. So that was about supervised machine learning algorithms. Coming to unsupervised learning, you have the input data, but there is no corresponding output variables. In unsupervised learning, what will happen is, okay, so you'll be trying to learn more about data. Why unsupervised learning is called as an unsupervised learning? Because there are no correct answers and there is no teacher. Algorithms have to devise their own mechanism to discover and present an interesting structure. Unsupervised learning, if you want to categorize them, they can be clustering problems and association problems. What is clustering? Grouping. Okay. So, so when you group, so in a group you have similar items such as customer behaviors. The other category of problems under unsupervised learning are association rules. Okay. So you'll be discovering rules that describe, say, buying trends. Now coming to few famous unsupervised learning algorithms are k-means and a priori. That was about supervised learning algorithms and unsupervised learning algorithms. Now coming to semi-supervised machine learning algorithms. Whenever you have a large amount of x and small amount of y, then such problems will be categorized under semi-supervised learning problems. Okay. A few examples mentioned in the book are photo archives, where few of the images are labeled and many of the images are not labeled. Okay. So labeling is a very expensive aspect because you require domain experts who will be labeling them, while unlabeled data is cheaper to collect and compile. We'll be using unsupervised learning techniques to discover and learn the structure in the input variable. If you are using supervised learning techniques, you will be making the best guess prediction for the unlabeled data. Then feed that back into the supervised learning algorithm as training data, and then use the model to make predictions on nuancing data. Now for the next topic from the syllabus as an introductory part, reinforcement learning. I have referred this book, Machine Learning, an algorithmic perspective by Stephen Marsland. So the contents are as is presented here. What Stephen Marsland says in his book, Machine Learning and Algorithmic Perspective as far as reinforcement learning is, it is presented here. In reinforcement learning, what happens is, information is provided about whether the answer is correct or not, but it will not tell how to improve the answer. The reinforcement learner has to try his own strategies. This trying out is analogous to search, and hence search is a most basic part of reinforcement learning. So in a reinforcement learning, there is an agent and there is an environment. So there is an interaction happening between the agent and the environment. Say for example, if you look at this diagram, this is a robot, okay, and there is an agent, there is an environment, there are sensors, okay, which will be used to perceive the environment, and there will be some action performed by the motors. Here, the agent is the learner, which will be trying to predict the next state and will get a reward. This diagram elaborates it further. This is the diagram for reinforcement learning cycle. There is a learning agent which will be performing an action AT at a state ST. Okay. And reward is what it gets, say, RT plus 1 from the environment, ending in a state ST plus 1. So this was few basics about supervised, semi-supervised, reinforced learning in today's session. Hope you like the session.